Chemistry is the study of change. It is growth, then decay, then transformation. Rumor has it that there is a new scientist in town, a rather rebellious one who opposes the norms in the world of chemistry. People say he seems to have done something that many other scientists would not have dared to. The theory of the atom has been credited to Niels Bohr because people have ignorantly believed it. It amuses me how something so significant be accepted so easily, showing how truly deceived people are.
Surprise! Happy birthday!
How does it feel to be 25?
It's alright.
Hey, Warner, come watch. Your Professor Bohr's getting a science award.
Niels Bohr? What is he getting an award for?
You know, the Bohr's model that says electrons move in a fixed orbit around the nucleus.
The one where he used the absorption and emission spectrum to prove it?
Yeah.
What? He doesn't deserve all this. His model isn't even right. Well, he's gonna get all this attention until someone proves him wrong.
I'm gonna prove him wrong.
All of my efforts go toward killing off and suitably replacing the concept of the orbital path which one cannot observe.
Finally got it. If only I can get this to Max Born. How could I reach him though? Jesse.
Yo, 148, 3 to the 3 to the 6 to the 9, representing the ABQ. What up, biatch? Leave it at the tone.
What do you want, old man?
Jesse, I need to speak to you about a new idea about the atomic theory.
Well, another idea. Why would I trust you? Your ideas never work.
Trust me, Jesse, it'll be worth it this time.
Okay, you know what? I'll give you one more chance. I'll meet you at your house in 5 minutes.
Listen, Jesse, I know you think Bohr's model is correct, but I'm telling you it's not. I've done my calculations, I've done my math, and I have a new model to propose to you, a new idea. First of all, Bohr's model explains how their electrons have a set orbital where you can know their exact location and position. Well, I'm here to tell you that that's not true, Jesse. Look, when you try to measure the location of where an electron is, you're essentially moving that location. We send out a photon to detect the mass, velocity, and location of an electron. However, but when we send this photon, we get the reading when it makes contact with that electron. Now, since our photon makes contact with that electron will move, obviously changing the velocity and location. We don't know what follows a circular path. It can be traveling in ovals, circles, or random shapes. However, like I said, we can know a rough idea, a probability of where it is. We can't know the exact location.
Whatever, man. I'm still confused.
Think about it like this, Jesse. Look at this picture. You take a picture of a ball. Imagine you throw a ball, you take a picture of the ball 3 times. Now in each of these individual pictures, you can see where the ball is, correct? Yeah. You don't know the speed, however, correct? Now look at a picture of all 3 of them combined. You get a blur of the ball. You don't know the exact position, but you know where it would be. The same way, we can't know the exact position and the exact speed at the same time of where the electron is. We can only get the probability, and with that probability, we can come up with orbital clouds.
get it. Honestly, Professor, I think you're onto something here. But I don't get these clouds.
Listen, Jesse, we're dealing with subatomic particles. They're so small, traveling so fast, we can't know exactly where they are. And these clouds just basically show us where they're most likely going to be. The denser the cloud, the more likely the electron is to be found there. I'm not saying Bohr is completely wrong. Yes, there are different energy levels, different orbitals, but the idea of an orbital being a fixed orbit is wrong. It's just a cloud. And I've come up with this principle. The position and momentum of a particle cannot be measured with high precision. Basically, you can't know the exact position and velocity of an electron. And I figured this out through complicated math, but that's what it is. And I need you to deliver this to Max Born.
Yeah, for sure. It's the least I can do.
Max, I think I got something worth your time.
Welcome to the annual Nobel Prize ceremony. My name is Max Born and I will be your host for today. Today we'll be acknowledging a very special man that has changed our understanding of the atomic theory. This discovery is very important because it proves our current understanding of the atomic theory is plausible. Now let's call up this very special man himself. And the award goes to...
Say my name.
Warner Heisenberg.
You're goddamn right.